For this Mass Effect lab, we have this rubric here that you're going to be able to follow to see the points and the description needed to get what points. In the document that you're going to be having this prediction here. This prediction, that's where I want you to try to make some reasonable prediction to the guiding question for this experiment. What is the effect on the mass of a system that has an increasing net force? So make a prediction. I have given you the materials and the procedure, so I want you to be precise about the procedure that you're given as well as the materials. The evidence, that's going to be these data tables where we have the mass of the hangar, the mass of the cart, and that total mass of the system, which remain constant for the entire time. This is the data that you're going to be able to use for your own experiment. So the data you're going to use is going to be these accelerations that we got from looking at the velocity versus time graphs. When we looked at velocity versus time graph, we saw the slope of it, which gave us these accelerations. So what you're to do is you're to calculate this tension force, and from that, you are going to be able to then calculate the theoretical acceleration as well as this experimental acceleration. In order to get this tension force, you have to get this mh times g. So what I mean by that is you're going to take this mh here, that's 0.025, and you're going to take that and multiply by g, which is that 9.81. So what I'm getting for us here is about 0.245, and it's going to be 0.245 newtons. So we're going to leave this in terms of newtons, and we're going to leave this here. You're going to have to do the calculation for the tension force for run number 2 and run number 3. And to get this theoretical acceleration, what it is I followed was these directions right here, where all you're going to be doing is taking the mh times g and divided by the total mass. So here, I want you to actually take a picture of you doing your calculation for run number 3. That's using this to get your theoretical acceleration. You have to take that mass of the hangar times gravity and divide it by the total mass of the system. The total mass of the system remained constant throughout the entire experiment. This acceleration changed due to the net force. This is the experimental acceleration. So you're going to find the experimental acceleration will be different than this theoretical acceleration. In this experiment, we assumed that there was no friction to do our calculation for the theoretical acceleration. The experimental acceleration should be lower than the theoretical, and you're going to see that we're going to get a percent difference. This negative is telling me that it's lower than what I theoretically expected to get. 0.42 is less than 0.43, and it's lower, negative, by this 2.75%. So I need for you to show me your percent difference calculation, where you take the experimental acceleration minus the theoretical acceleration, divide it by the theoretical acceleration, and multiply that value by 100%. Getting into the analysis, I want you to actually then try to analyze this data, saying why is the acceleration in run number 3 greater than run number 2? Explain the motion of an object when the net force is 0. I will tell you right now, it is not that the motion of the object is motionless. It could be motionless, but that doesn't mean it's always motionless when the net force is 0. Compare that to an object that has a net force greater than 0. And then lastly, I need for you to use Newton's first, second, and third laws in order to describe the motion of this cart. So, if you watch my Mr. E Explains, you can see in there how we use Newton's first, second, and third laws to describe the motion of this cart. Finally, to the CER, I've given you some guidance here on how to write out this CER. It doesn't mean that this is a CER. In fact, this is not a CER. So if you just kind of turn this in, then this will not count because I need it to be one cohesive argument. This is just a guide. I'm trying now to wean you off from my pre-written CERs. So the CERs I've given to you in the past have had sentence starters and some other guidance for you. You can refer to those to see how to write up a CER and how to make it appear. For us, we can have this as a guidance. We also have used this to guide for your CER. So this gets into the parts of a CER, talking about the claim, the evidence, a mathematical model. So for us, our mathematical model is going to be that F equals ma. The evidence, that's going to be the evidence of your theoretical acceleration as well as the experimental acceleration. That experimental acceleration will be the data that you have to describe the relationship between the force and the acceleration on the object. We are to make a prediction. So we need to make some kind of prediction on what would happen to the system if we were to do some other different type of force, some force that we did not necessarily test with respect to our system. And then you need to justify, explain your thinking and your confidence here for your data in order to predict this future behavior. So an example I gave for this prediction was, with a larger net force of around 100 newtons, you could predict that the acceleration of the object would be 177.3 meters per second squared, based on your mathematical model. The mathematical model being this F equals ma, which we can just kind of wink to one another and say that that's Newton's second law. So use this as a guidance. This is not your CER, but rather it's a guidance for you in writing up a CER. Once you're done with this, you're able to turn in this laboratory experiment